But see, this particular equation, although it looks good, it will not work fine in some cases. Okay, whenever we have some outlier points, this is not the equation which will give the optimal W. Okay, to explain my point, I'll show you an example. Please focus. Let's say we have an example like this, where we have some positive points like this. Okay, and we have some negative points like this, say 5 negative points and 5 positive points, and let's say we have a negative point over here. Okay, now let's say we have a plane like this which separates, let's say this plane is pi 1, for example. Okay, and the distance of all this is W, let's say. Okay, and the distance of these points from the plane, let's say, is 1 unit, all of these points. Okay, let's say we have 1 unit, and from the negative points also we have, let's say, 1 unit. Okay, and let's say this particular point is at a distance of 100 from the plane. Okay, now what is the issue? Let's see. So here, what is our goal? Our goal is to find out yi w transpose xi, sorry, w transpose xi. We want to find all of these values, right, from I equals to 1 to n, right? So now you see, for this point, let's talk about these points. Okay, so this distance is basically 1, right, and it is on the same side of the plane. So what is the distance? It is plus 1, right? So here yi w transpose xi, so this particular value is positive 1 for this particular point. And what is yi? What is the actual value, actual class of this particular point? This is positive, right? So positive 1. Okay, so positive 1 into positive 1 is basically positive 1. What about this point? Again it is plus 1 into plus 1. So for these we have this value as 1 plus 1 plus 1 plus 1 plus 1 for all these 5 points. What about this point? This negative point is on the other side of the plane on which the W is pointing. So this particular distance W transpose xi is basically minus 1. And what is the class of this point? This is minus 1. So minus 1 into minus 1 is plus 1. So again we'll be adding plus 1 plus 1 plus 1 plus 1 plus 1, right? Done. So now what about this point? This is a negative point which is on the positive side of the plane. So what is the distance? The distance unit is 100, but it is on the positive side, so the distance is plus 100, right? Plus 100. But what is the, let's say this is 100, right? This is plus 100. The distance is plus 100 because it is on the same side of the plane where the normal is pointing. What is the class of this point? True class, it is minus 1. So minus 1 into 100 is minus 100. So here minus 100. So what is the result? So this is 5, this is 5, 10 minus 100, which is minus 90. Okay, so we got some value, right? Minus 90. This particular value is minus 90 for plane 1. Okay, now we'll see a different plane. Let's use a different plane. Let's say I'll again use the same points. So let's say plus 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 plus. Say we have 5 points here, so we have these points over here, the negative points. Okay, and we had a negative point over here, right? Now let's say I'll be using some different plane. Let's say I'm using a plane like this. Okay, let's call this plane as pi 2. Okay, and the normal is pointing towards this side. So now let's say this distance is 1, this distance is 1, this distance is also 1, and inter distance between all the points is 1. Okay, inter distance between all the points is basically 1. Let's assume this. Okay, now what will be the result? So yi w transpose xi, right? How do we find this value? So for this point, it is a positive point, so basically this is +1. And what is the distance from the plane? It is again +1, so this particular value is again +1. So this is +1 into +1, so I can write here +1. For this point, the yi is +1, and what is the distance? The distance, this is 1, this is 1, so 1 plus 1 is 2. So it is basically at a distance of 2 from the plane. From this plane, the distance is 2, so this is +2, right? So 2 into 1 is 2, so I'll just add 2. Next, for this point, the yi is positive and the distance is 3, right? Positive 3, because it is on the same side of the plane. So 1 plus 2 plus 3. Likewise, 1 plus 2 plus 3 plus 4 plus 5, right? For all the 5 points. Next, what are the negative points? Here, the negative points, the actual yi is -1, right? And what is the distance? Distance is again +1 for this point. So for the next point, what will be the result? -1 and +2. So what will be the multiplication? So -1, -2 likewise. So I'll write -1, -2, -3, -4, -5 for all these points. Done. What about this? This point is on the negative side of the plane and it is a negative point. So it will be basically negative, class is negative, and the distance is on the negative side, so it is -1. So it will be -1 into -1 +1, right? So you can see we can cancel this all out. So we have the result as +1. So this is 1. So now look at the earlier value. This was -90. For pi 1 we had, so for pi 1 we had the, we have the value as -90, and for pi 2 we have the value as 1. So which is better? Which we wanted to maximize it, right? We wanted to maximize this value. So what is the maximum value? This pi 2, right? But look at pi 2. Pi 2 is a terrible classifier. What is the reason? Here it is classifying how many points? For first look at this pi 1. Pi 1, how many points is correctly classified? Correctly classified points are these, all the 5 points are correctly classified. These, all the 5 negative points are correctly classified. Only misclassified point is this. So out of 11 points, 10 points are correctly classified. So the accuracy is very high, isn't it? Only 1 point is misclassified. This point is classified as positive point, although it is a negative point. But all the other 10 points are correctly classified by the classifier. But on the other hand, you see here how many points are correctly classified. These 5 positive points are correctly classified, right? And this particular negative point is correctly classified, if I'm not wrong, right? Because this is on the negative side of the plane, so it is basically classifying it as a negative point, and it is actually a negative point. So this is correctly classified, and these 5 points are correctly classified, these 5 positive points. But all these 5 negative points are incorrectly classified as positive points. So what is the accuracy? So 6 out of 11 points are correctly classified. So this is a terrible classifier, believe me. So but here, according to the equation, pi 2 is better. It has got a higher value than pi 1, right? So pi 2 will be selected, but pi 2 is very terrible classifier. So here in this case, the classifier actually fails. What is the reason behind it? The reason behind it is the impact of outlier point. This particular point is called an outlier point. Outlier. Okay, so you already know the concept of outlier, but still I'll just reiterate. A point which is exception, right? See, all the points are within one distance, or they are clustered together, but this point is far apart. Okay, say the human heights are from, let's say, in the range of 3 feet to maybe 6 or 7 feet. But let's say there is a data in my database or in my data set, which says the height of a person is 20 feet, right? Now that is called an outlier. Okay, either it can be an exceptional value or it can be a mistake. Okay, it can be a mistake. So those kind of data will impact the data, impact the classifier, how the classifier will classify the points. It will impact it. So we have to solve this problem. Because of the outlier, we are getting the result which is not intended. If there was no kind of outlier, then this classifier would have worked fine. But since there is an outlier, there can be outliers, right? In our data set, we never know. So here it terribly fails. So in the next video, we'll see we'll just modify the particular classifier, the equation, in such a way, keeping the crux of the equation same, and you will see it will work well, pretty well for outlier points also. Okay, so see you in the next video. Thank you.